Hello, people who aren't here in class.
Pineapple.
The real question was, is it going to be on the test?
Hello.
It's gonna be on the test next week.
I
Yeah.
wanted to watch this video again.
Hello
It's
to
probably
myself.
gonna be me.
My future.
So hello to your future self. Okay. Okay, so here's the deal. What's wrong with this right here?
I don't understand it.
Separated.
Okay, can we get x's on one side, y's on the other side, to where we can integrate both sides, dy and dx? No. What's the big problem? This addition with a function with x and y. That's the problem. Okay? Before, we could like multiply this over, divide this over, and yay, we separated our variables, we can go forward. Okay? We can't do that here. Okay? So, what?
We're gonna factor. Can you factor out a y?
I could pretend you didn't say that. We cannot factor out a y. Why?
Because that's not how it works.
Okay, because this y is connected with the d,
Yeah.
right? It's not like d times y, it's dy. Seriously. Okay, so write down this standard form. And we need to choose a u of x to be our integrating factor. So maybe you should write that down first. Okay, we're going to choose u of x to be our integrating factor where this is the rule. Okay. I will tell you why here in a moment. Just right here, so I'm not in your way. Okay, here's the deal. I'm going to take you on a journey through why the method that we are going to use will work. Kind of like what we did with the logistic growth. Oh, it's not that complicated. Okay, it's not that long. We're going to go through the why, and then we will just get to use it. Does that make sense? Okay, I can just tell you, pick u to be blah, 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 blah. But if you don't know why it's going to work, what's the point of doing it? Okay? So we are strategically going to pick an integrating factor to where the integrating factor times p is going to be u prime. Well, let me show you what I mean by that. Okay. We have our standard form. Our integrating factor. We're going to multiply everything by our integrating factor. So we're going to multiply it to the left side. And we're going to multiply it to the right side. Okay, if we strategically pick u of x to where u of x times p of x is u prime, right? U of x times p of x is u prime. Let's go ahead and replace that. Doesn't matter the color of the marker, it matters where you place it. Okay, this is why we're going to strategically do this. Look at the left side. Look at it closely. Analyze it. U times dy dx plus u prime times y. Observations? U times y prime plus u prime times y.
Well, u of x dy dx is the same as u prime of x.
No. dy dx is y prime. d dx is what you're thinking of. Okay? Okay, say it out. All three of you know it.
It's a product.
Product.
It's the product rule, right?
Oh yeah.
Yeah.
Wow. That's
So if
great.
we strategically make our integrating factor to where when we multiply it by p, we have u prime, then we create the product rule. So we know that this right here means, hey, take the derivative of u of x times y. That's what that means, right? That's the derivative of the product. So if we can force that to look like a product rule, we can write it as a product. Hey, do we have addition anymore?
No.
We don't have addition anymore. So now what we can do at this point is we can now integrate. And what happens when we take the integral of a derivative?
Just get this stuff inside.
Okay, so what's going to happen is we now have u of x times y equal to some integral that we can probably solve, and then we would be able to divide u of x over to solve for y.
So,
Okay, now to be honest, what we did right here will be most of your work when I tell you how to identify u. Okay, I'm going to show you the math behind how we need to identify u. Okay, like u of x, not. But then this will be what a lot of your work will look like, but with equations, or excuse me, functions thrown in there. Okay, so would you like to know the math behind u?
Oh yes.
I appreciate your enthusiasm today. Okay, so let's go back to our integrating factor. U of x is our integrating factor. Okay, and we want u of x times p of x to be u prime so that we can force that product rule. Jackson, are you going to stay for this? Or do you need to leave?
I'll probably leave at like 10:10.
Oh, 10.
I'll be here.
I don't know why I thought that you meant earlier.
Nope.
So you have to see it easy. Okay. All right. So, you ready for this? Can we rewrite this to be u prime of x over u of x? Okay. U prime of x over u of x. I feel like that's very familiar. Why is that so familiar? It's the derivative of the natural log of a function, and in this particular case, our function is u. Okay, so we could rewrite this right here as the derivative of the natural log of u of x. Too many? Okay. So now, we're going to integrate.
Absolutely wild.
So I'm going to keep this. We know nothing about the integral of p of x because we don't know p of x. But we do know that the integral of a derivative would be
Just the stuff in the middle.
Yep. That kind of looks funny, but feel with me here. And we are going to have that plus c, okay? Yes.
So when we have like u of x and y, do we have to have a plus c there too, or like
Say that again.
so like when you have u of x, y equals the integral of qx ux dx,
Mm-hmm.
do you have to have a plus c there too? Or?
We actually do not, because when we substitute this in, it's going to make up for it. Okay. I think there may work here. Let me go back. I'm thinking of this case. We will have a plus c when we do our integral, because over here we end up with, like you're talking right here. Okay, we'll put our plus c when we do this integral right here. We'll get a plus c when we do that integration. Okay, and because we do that, that's going to help us here. This c is eventually not going to matter, and I'll show you what I mean here soon. Okay, all right. So our whole point of doing this is we want to know how the heck to identify u of x, right? So let's solve for u of x. How do we do that? So we have e the integral
That looks wrong.
of p of x. What? I'm just gonna write k times the natural. Oh, why am I writing a k there?
Because k is just a pretty letter, I guess.
Okay. Well, we have e to the c, right?
Yeah.
So like this cancels out, but we still have times e to the c, and so technically we have a constant over there. Because yeah. But what happens is we actually don't have to worry about what that constant is, because when we plug it in to our equation, it's going to cancel out. Okay? So we don't have to worry about the constant in this case because it will kind of undo itself, essentially. This is our integrating factor.
That's disgusting.
I love that.
Two things you need to take away. That's standard form. And this is how we find our integrating factor. Okay, I've shown you the math behind it. If you have questions, let me know. I'm not going to ask you to show me this math behind it, but I wanted you to have an understanding of where I'm pulling these random letters from. Okay? So any questions before I tell you how to actually do the problem? Okay. I love that I'm staring at like two of Mean's face like everywhere. It's like everywhere. I'm seeing double. Okay.
What happened to the seniors wearing blue?
There's
Like,
six.
real talk.
Okay, so our steps to solve our first order linear differential equation. Say that 5 times fast. Don't do it. Okay, the first thing, it needs to be in standard form. It needs to be in standard form. So if it's not, get it there. That's what it looks like. dy dx plus some function of x times y equal to some more function of x. Then, using this little guy that we came up with, that you're all very partial to, you're going to identify u of x. Then we're gonna go through that process that I showed you on that second slide, the first slide I wrote on, okay? We're gonna multiply both sides of our standard form by the integrating factor so that we can force it to look like a product rule. Once we force it to look like a product rule, then we'll rewrite it as a product rule. Apparently I can change the color, look at that, guys.
Magic.
All I wanted was to exit out. And then we can integrate and solve.
One question.
Yes.
So when we got our driver's license this last
Uh-huh.
year, and they were like single variable equations, is this still that?
It is still that.
Darn it.
Multivariable is what you get to in calculus 3.
Oh,
You'll be doing you'll be doing double and triple integrals in terms of like with x and y. Like if you look in the back of your in the last few chapters of your calc book, it has calc 3 stuff in there, and you can see double and triple integrals. Not right now. Not right now. But I'm glad that you're interested in that. Calc 3 was my favorite, by the way.
if we have, when you solve for y, if we have that y equals equation memorized, can we just do that and not do the rest of the work?
What?
I'm sorry, what?
Like if we have it memorized that what y equals when you do all this stuff, do you have to do the rest of the work? Because like, if y
Can you just
equals
like tell us what you're talking about?
if y equals the integral of ux qx dx plus c over ux, can we just like plug it all into that instead of?
What do they teach you?
You're like, what?
What's it called? A, B, and Virginia.
She's over here doing calc
She's
freaking
saying
PO.
just divide UX over.
I see what you mean.
Can we just
I mean, yeah.
plug it?
It's
Because that's,
like
that's how we
alphabet
learned to
soup.
do it. We just had to just memorize that.
Yeah.
So it's like,
If you want to memorize and do that, that's fine.
I mean, I've already have it there, so it's
Okay. All right, so let's talk about this one. Is it in standard form?
No.
Why not?
X.
X is being multiplied by dy dx, and I want dy dx to be alone. So how would we fix that? So we have, do you want me to keep it as y prime, or would you prefer dy dx?
Yes.
So dy dx. Why am I going to write plus there? Standard form has plus. A function of x times y equals a function of x. Step 1, we have it in standard form. Step number 2. We need u of x. U of x is e to the integral of p, which is negative 2 over x. Yeah. Okay, so what is the integral of negative 2 over x? Okay, technically, yeah. All right, so this is e to the natural log of x to the negative second. Boom, those cancel. 1 over x squared. That's nice, isn't it? We don't have to deal with e. So we are going to multiply everything by our integrating factor. So we have 1 over x squared dy dx. I'm going to go ahead and write it here. Minus 2 over x cubed times y equals 1 over x squared times x would give us 1 over x. Okay. What you need, and I would suggest doing this work just to check yourself. Okay. Is this the product rule for y and 1 over x squared? Is that the product rule for y and 1 over x squared? It's yes. Yes? Okay. So we are going to rewrite this as the derivative of 1 over x squared times y. And then we can integrate both sides. So integral of a derivative cancels out. What's the integral of 1 over x? Natural log of x. Lillian, here's the plus c. We are going to put it. Okay. So then to solve for y, we're just going to multiply that x squared over. That's a c. Got a little curly Q there. Okay. We've solved for y. We've done our work. Okay. Then x squared is being multiplied to c. X squared is not a constant, so we can't take a shortcut there. You can multiply x squared through, but that's just more work. You can leave it like this. Okay. What do you think?
I thought it was pretty crazy. I thought it was going to be worse than it was.
Okay.
It's kind of the
Write this one down.
Show these notes to one of my friends in lower math.
That's what I do now. Like,
Yeah, listen to all these. None of these are even numbers.
they're over here like limits are hard, and I'm like, man,
we haven't even learned anything.
Stop.
Until that.
False.
Euler.
I mean, we learned Euler's method. but
Yeah, and logistic growth.
it's Euler.
those, we've talked about all of those things before.
Lice minus lit.
We didn't learn a formula. It's not a graph.
Fine.
That was kind of funny when Darby was like, I'm reaching my point in physics.
We make physics
Carrie.
jokes in calc, we make calc jokes in physics. It's just one big fun.
It's a happy world. Okay. Is this in standard form?
Wow.
All right. Then help me out. Well, I wouldn't divide yet. You would need to add dy over first, right? And then divide by dx. And that's not really how we want it. We would want y times cosine of x plus y times 1. Right? Times cosine times 1. My apologies. I distributed a little bit.
Oh. I forgot distribution was a thing.
Yeah. Okay. But is this still even in the right order?
No.
No, we would need to write it as, I'm going to move dy dx, I'm going to just dy dx minus y cosine x equals cosine x.
Doesn't have to be plus.
Aha, yes it does. So let's go ahead and change it to plus negative cosine xy. Bye, Jackson.
See you guys.
Can't wait to see you.
Is it
Excited.
cosine of xy or is
Just
it
proud.
negative y cosine of x?
That's kind of funny.
Represent calculus.
Maybe we should write it that way so we don't get that confused. I was trying to write like function of x times y, but yep. Nope, you're right. You are right. Okay. All right, so what is p of x?
Yes.
Negative
Negative
cosine.
cosine of x. So our integrating factor.
Negative cosine of x since you have to. Oh wait, no, you just.
Oh, I'm flipping it. That's honest mistake.
So e to the integral of negative cosine of x dx. So what's our integrating factor?
E to the sine of x. Negative sine.
You know that scene in Incredibles 2 where she's like, math is math? That's out of it.
Hi, Jackson.
Why would they change that?
We should say hi to Jackson.
There's too many letters.
What's the
Because
Code
Jackson's
word.
probably gonna watch this. Yeah, we should. What's his code word?
Need.
Need. That's the code word.
Pineapple.
Okay,
I can't
what do we do with our integrating factor?
Pineapple.
multiply.
Multiply to both sides. So we have e to the negative sine of x dy dx plus y times e to the negative sine of x times negative cosine of x equals e to the negative sine of x times cosine of x. And some of you get excited about that, right? You know what's coming. You know what's coming.
You wrote it a different way than I did. You're trying to like process it.
Okay, so let's rewrite this as our, first of all, is this the product rule of y and e to the negative sine of x?
Yeah.
Hannah's not
Yes.
convinced.
Yes.
She's convinced. She's
Yeah.
convinced.
Yes.
So this is the derivative of y times e to the negative sine of x. So at this point, we can integrate.
Teachers, please release the varsity band and color guard at this time for the pep rally. Yes, the varsity band and color guard. Thank you.
Jackson's already done.
Man, it's just us.
Okay, we can do U substitution in this, right?
Oh yes.
U equals
Negative
negative sine of x. Du is, okay, so our antiderivative would be negative e to the u plus e. Would anybody like me to show my work there?
No, I understand.
Hi
We
Hannah,
better,
welcome
like,
to the video.
just
That
focus
was
on
another
the
code word for Hannah.
14
Yeah.
problems.
How about Jeffrey
Squidward.
David Allen?
Who is Jeffrey David Allen?
need?
Secret.
Is it me? Is that his actual name?
So then we're going to divide both sides by e to the negative sine of x. Oh.
Y equals Z.
Wait,
No.
are we dividing by e to the negative sine of x or negative e to the negative sine of x? Okay.
Y equals negative Z.
I got excited with my negative sign there.
It's okay. We all get excited about negative signs.
Okay, so what happens? Negative e to the negative sine of x divided by e to the negative sine of x is
C minus 1.
negative 1.
Plus Z.
No. Plus c times e to the sine of x, people.
Oh, because
Yeah.
You can do the little, oh, okay.
Spam.
I see.
Okay, so first of all, c is being divided by e to the negative sign of x, so they're attached, but a negative exponent could be moved up to the numerator.
What is it?
So instead of c divided by e to the negative sign of x, we can write c times e to the positive sign of x.
I'm glad
That's
this
the answer.
difference on the AP test.
Ooh.
You know what though? Nobody stopped me from doing this.
What stopped you from doing this?
I don't want to
The calculus, please?
get. Ooh.
I would be happy if there were.
Uh-oh, she's writing something up. Guys, you can't see what she's writing.
Okay. When we made dy dx, right? We had y plus 1 times the cosine of x.
You're gonna. No. Yeah. Separation of variables. Why?
We could have done separation of variables.
Why didn't we?
Hey, you guys are funny.
Yeah, she's gonna have a problem in the test. It's like, and then compare your answer if you did the separation of variables. And there's gonna be just
That's
like
not
an
going to be a question on the
audible,
test.
audible
Okay.
sigh in the class if you have to.
So you all understand that separation of variables is much nicer.
Yes.
But we can't always use it, so we fall back on this first order linear differential equation. Okay. I love Bronies for excited. Do you like that? Your homework is 1, 2, 3, 4, 5, 6, 7 problems. And it's your first book assignment.
This is not a good
Put it on my locker.
My suggestion, because we have 7 minutes left, try to get one problem done. I'll write it down for you. Number 1 is
I don't want to get it.
dy dx. I mean number 5.
Is that the number we start on?
Plus, yes, 1 over x times y equals 6x plus 2.
Could you give us the assignment, please, just so we can write it down?
Don't you have your goal sheet?
Oh yeah, forgot that existed.
Yeah.
This is
Yes.
Hey, go
Take
put
the
your
test.
thing away.